Hello everyone, today we're going to talk about a very important topic in algebra, which is quadratic functions. So before we jump into it, let's talk about what a quadratic function is. So we're going to start with drawing out two xy planes. Since it's a function, it's an equation that we'll be mapping out on a plane. And the general idea, which we can see by looking at these two, is that it's going to create this U shape. And for these ones, the equations I will give to them is y equals x squared and y equals negative x squared. So some of the key features when it comes to a quadratic equation, just to help you spot it, would be one, that it's symmetrical. It's going to be symmetrical about the y-axis, which is this one going down the middle. You can see that if you split the u in the middle, both sides are going to be symmetrical. Two, the way that I would describe it is that it's exponential. So if you're familiar with an exponential equation, you know that over time it increases at a faster and faster rate as you go to the right or go to the left, depending how the equation is. It's going to be increasing more and more for every x that you move over. And this is a pattern that we can see in the quadratic function as we go more over in each direction. The steepness or the amount that you're increasing for each x that you move over becomes more and more. So those are kind of the two main ideas of a quadratic function, and it will help you just identify it if you're looking at it on a graph and maybe you're asked, hey, what kind of function is this? So just having a general idea of the shape and how they acts gives a lot of insight into equations and how to solve them and the nature of the problem. So keeping in mind these two, we're going to talk about the general equation and then kind of get into some general ways that the equation is manipulated, how it's moved around. So the general equation is going to be a times x squared. If you write two variables by each other without saying anything, it just means they're being multiplied, plus bx plus c. Now, an interesting idea with this equation is we don't have to use every single part of it. So when it comes to the basic y equals x squared or y equals negative x squared to flip it, we can see that we're only using this first bit. So in the above equations, we're only using a x squared. We're not using bx, we're not using c, and that's perfectly fine. But you cannot use just bx and c, that would be a linear equation. You can't just use c, that's just going to be a number. So you have to use that first part, and then you can choose to use bx or c. And then that just means kind of different things for the equation. We'll get into that. But just know that the ax squared, that's the important part of the equation that makes a quadratic a quadratic. Bx and c just change how the quadratic acts. Okay, so with that in mind, let's talk about some common manipulations. We'll just call them movements. Simplify it, call a spade. All you're basically doing is moving around these equations. So in my opinion, there's basically three main movements we're going to have. So we're going to start with y equals x squared, and we're going to talk about manipulating this because that's where you're going to see it mainly manipulated. Once you start manipulating the entire equation, it gets a little confusing, but just knowing how it moves at the basic level is kind of important and will allow you to look at how it moves at different levels. So going from y equals x squared, we're going to have three different types of movements here. Okay, so the first one, we're going to be moving it left to right. We're going to write that in y equals x plus c, parentheses, squared. And we write this in parentheses because we're squaring everything on this inside. That's a very important factor of it. And when we draw this out, we're going to compare it to the basic. So y equals x squared. And then let's say that c is 3. So we're going to write that out up here. X plus 3 squared. Okay. Now you can plug in numbers to see how this moves about, and that is definitely a way to approach it. However, if you know the general rule, it's a lot easier than it may seem. Whatever you're doing on the inside of this parentheses, it's going to be the opposite. So I mean that in terms of addition and subtraction. So if you're adding 3, you're going to move to the left. If you're subtracting 3, you're going to move to the right. So let's just write that over here. Plus is left, minus is right. And that's kind of opposite of what you would just initially think on instinct. And the reason that it acts this way is you have to think what's going to get the start back to 0. So when it comes to y equals x squared or y equals negative x squared, when you want to be at the point of origin, which is that middle point of the plane. So to get there, you need to get x plus 3 all squared equal to 0, because that means when you plug in the number, you're going to be getting a 0 output for the y, which puts you on the x-axis, and you want to be on the 0 of the y-axis. That's the best way I can explain it. Just know that if you're adding on the inside of the parentheses, you're going to be moving to the left. If you're subtracting on the inside, you're going to be moving to the right. So since we're adding, we know we're going to move to the left 3. Okay, so let's say this is 1, 2, 3. We're going to start here. And then from there, the equation is the same. We didn't alter it in any other way. So we know that at x equals negative 3, we're going to be at y equals 0. And we can see that's true because if you plug negative 3 on the inside of this parentheses, it's 0. 0 squared is 0. And nothing else about the equation changes. And now this one is symmetrical about x equals negative 3. So that's that middle point. That's where the parabola peaks or hits the bottom in this case. So it's symmetrical about that point. So that's just moving left and right. Now let's see another example. Let's say we have y equals x squared, like the normal quadratic, and then plus c. So we can still have the idea that we're going to start with a normal quadratic, which is y equals x squared. Arrows means that it goes forever in each direction. And these aren't going to be perfect. Just know that it's symmetrical and always follows that same general look. Now when it comes to y equals x squared plus c outside of the parentheses, that's completely different. So x plus c squared in parentheses means that you're moving left and right. When you have x squared plus something, it means that every point is just going up by c, whatever number you choose. You can just imagine that, let's say we have y equals x squared plus 2. There's basically two parts of this. There's y equals x squared, which is what we know, that's the normal quadratic equation, and then there's plus 2. So that means we're going to have the normal quadratic equation plus 2 for every single point. That might be slightly confusing to start, but what it's going to mean is that we're just starting at 2 higher, and then we're doing that normal pattern that we see. Okay? So again, you can just plug in numbers and see that every single point you have will be going up by the amount that you increase. So plus means you go up, and minus means they go down. So if we're going to subtract by 2 instead of add by 2, we would start at normal y equals x squared, and then move every single point down 2 units. Now the final movement that is pretty important to note would be, let's see here, we're going to have y equals x squared minus, oh, no, let's see, not quite, jumping a little ahead of myself there. So we're going to have y equals negative x squared, and we showed this up ahead, sorry about that, jumping a little ahead. And all this means, we'll draw the basic y equals x squared on this left, and then let's have another chart over here. And this is going to be y equals negative x squared. Okay? Now we wrote that up top without the parentheses, but it is important that the parentheses is there, because if you were going to have y equals, in parentheses, negative x squared, everything on that inside the parentheses is just going to be turned into a positive value. And that doesn't necessarily do what we're looking for. Instead, when you have it outside of the parentheses, you're going to be flipping it about the x-axis. So you're just mirroring it. And we see that up here. We have the original y equals x squared, which goes up in each direction. And when you take a negative on the outside, it's going to flip it. So keep in mind that all these rules can be interchanged with each other. And that's just an important thing to know, that none of these really affect each other necessarily. Some of them can definitely, but you can just take them one step at a time, and you can apply multiple movements to the same equation to make a new equation out of it. But the important thing is that you start at y equals x squared if that's your given equation, and that you just move out from there. So take it one step at a time, and then just draw your new chart out. And you can always just plug in x values to get y values to figure out what that chart is going to look at. But your teacher might want you to specifically know how these rules affect the quadratic equation. So moving beyond movements, we're going to go into factoring. Now this is probably where you'll spend the majority of your time when it comes to quadratic equations, so it's very important that you understand how factoring works. Before we get into the main method of factoring, we're going to go over some of the easier examples that you might encounter, and if you're trying to do the main way of doing it, it might be confusing, but if you take a second and realize, hey, I actually have an easier problem here, it's going to make your life a lot easier and the equation go by faster. So we're going to write out a couple of these. We're going to have y equals x squared. For the next one, we're going to have y equals x squared plus 2x. For the final one, we're going to have y equals x squared minus 4. When it comes to factoring, what does factoring even mean? You're going to break it up into smaller sections, and you're going to find what causes y to be 0. So we'll write that down. Let's see. So we're going to first break it into sections, and then we want y to equal 0. And we'll see why that's important on the charts when it gets to the actual factoring process. But first, let's start with these 3 examples that are supposed to be slightly easier than the more confusing way. So when we have something like y equals x squared, all that we have to do is make x 0. And we can see that if we put x squared equals 0, well, what's squared equals 0? We know that x equals 0. So in that case, which we can draw on the simple chart, we know that it's going to touch the x-axis at x equals 0. And that's just kind of the simple example, very basic, but I mean, it's a good starting point, especially when you're trying to grasp the idea of what we're going at when we go for a factor. And now we're going to have x squared plus 2x equals 0. And when you have if you go back to the equation up here, ax squared plus bx plus c, if you have ax squared and bx, that's this form that we're seeing up here. And all you have to do is pull an x out, and what that's going to look like is x times x plus 2. And we'll still set that equal to 0. Now, why can we do this? It's because these two things are equivalent. They're equal to the same thing. If we multiply the x back into the parentheses, we're going to get x squared plus 2x. And we know that is equal to 0, so we can say x times x plus 2 is also equal to 0. As long as the two equations are the same, we can still say that they're equal to the same value. And in that case, we're looking for when they're equal to 0. And now this general form is kind of giving us an insight into what it's going to look like in future problems. We know there's going to be 2 different x's in this case, and that might not be immediately obvious, especially if you haven't worked with quadratic equations. But where you're going to get these 2 from is outside the parentheses and inside the parentheses. And that's because you're multiplying these 2 values. And when you multiply anything by 0, it's equal to 0. So either we want to make x 0, or we want to make x plus 2, the thing we're multiplying by x, to be 0. So we can either say that x is 0, and that 0 times x plus 2 is equal to 0, because anything multiplied by 0 is 0, or we're going to find when x plus 2 equals 0, and that x times 0 is 0 because anything multiplied by 0 is 0. So in this case, we can say for x plus 2 equals 0, and we solve for that, which is going to be x equals negative 2, just subtracting 2 from each side. And we can see that when we plug in negative 2 into x plus 2, it's going to be negative 2 plus 2, which is equal to 0. So the main idea when you're factoring out these more complicated ones is that you're going to be multiplying two things, or maybe more in some more elaborate and complicated examples. So you want to find when any one of the parts is 0, because when you multiply anything by 0, you multiply million, x, y, z, t, p, variable, whatever. It doesn't matter because anything multiplied by 0 is 0, and that's going to say when it's at 0. So that is important to keep in mind, and we're going to come back to this example shortly, but for now let's just solve this final one. So this is slightly easier. X squared minus 4, we want to know when that's equal to 0, when y is equal to 0. So we're going to add 4 to each side. We have x squared equals 4. And now the way to solve for this, if you haven't seen it before, we can say that's the square root of x squared equals the square root of 4. And that's going to be x is equal to plus or minus 2. Now if you haven't worked with quadratic equations, this is probably the first time you're seeing a plus minus answer, and this is definitely the first time that I saw it, and it's confusing at first, definitely. So the best way I can explain it is we're going to look at both these answers. We're going to have negative 2 squared, and we're going to have 2 squared. And when we write that out, we're going to have negative 2 times negative, let's say negative 2 times negative 2. Negative times negative is a positive. 2 times 2 is 4. And then this one is just 2 times 2. Basic multiplication, we know that's 4. So a negative, when it's squared, turns into a positive. So we want x squared to equal 4, and negative 2 and 2 are x values. So there's two answers for the square root of 4 in this case, and that's negative 2 and 2, because both turn into positives when they're squared, and they're positive 4 values. And that's what we want to see. And now this will make sense when you kind of look at how the general quadratic is shaped. I guess none of these examples up here particularly do it well, but looking at a chart, let's just say, yeah, I suppose we could draw this one out a little bit. So we know that x squared minus 4 brings the equation down 4 units. And then beyond that, it's going to look like a normal quadratic equation that typically goes up a little higher than what we normally see because we're starting lower. But we know that y is equal to 0 at negative 2 and 2. So that's the idea of having two answers. It's because it crosses over that x-axis twice. And since it's symmetrical, they're going to be equal distance from each other. So we can see that again in the second equation, which I kind of wanted to talk about. Y equals x squared plus 2x. And we're going to just plot some of this out. So we plug 0 in, we're going to get 0. Let's do another color. Let's do blue. If we plug in 1, we're going to have 1 plus 2 equal to 3. Okay. And then, yeah, let's see. Okay, yeah. Yeah, okay, no, that makes sense. Okay, so yeah, we plug in 1, we're going to get 3. Let's plug in negative 1 plus 2 times negative 1, which is going to be 1 minus 2, which equals negative 1. So negative 1, negative 1. And now we know that the other answer is x equals 2 up here. Sorry if I'm jumping around a bit. Well, the other answer is x equals negative 2. So let's plug in negative 2 into it. Negative 2 squared plus 2 times negative 2, which is 4 minus 4, which equals 0, which makes sense. So we know that x equals 2. Well, x equals negative 2 is at 0. So then from a couple of these points, we can just kind of extrapolate and draw what our quadratic equation is going to look like. So it's going to be something like that. Again, not a perfect drawing, but that's a general idea where if you needed to draw, that's how you could work it out. You could plug in points. You could use the values that cause it to be 0, and then kind of draw about that point as well. So again, we're taking this one from number 2 up here. and that one says that x can equal 0 and x can equal -2, and that's when y is equal to 0. And we can see that in these 2 points right here. And then when you have those 2 points and you kind of find where it peaks, it's very easy to draw from there, just pretty straightforward. So before we move on to a very difficult kind of example, and the example you're going to often be seeing when it comes to these, I did want to talk about the, well, not intercept form, but let's see. Let's just call it the peak. So you're going to have your standard equation, which is a equals x squared plus bx plus c. And then we kind of know what that looks like. You're going to have the quadratic equation. Let's just say something like that. Doesn't have to be true for any specific value, but general pattern of what we're going to look like. And we know that for that, or for the opposite, just say something like this, we're going to have a peak point. And that's either going to be at the very bottom or at the very top. And your teacher might want to know where that point is. And that's a great thing to wonder, because we want to know when something's at its top or something at its bottom, especially if it's a story problem and it has importance. A quick way to find that is this form, -b over 2a, and that's just going to be the peak or the bottom. And we're going to say x equals, because this is going to give us an x value, and you can plug that x value into the equation to find your y value. So let's look at our prior example, kind of to test that out. So we have y equals x squared plus 2x. Okay, there's a 1 in front of this, which we just don't see. That's going to be a, and then this 2 is going to be b. So we know that its peak is going to be at -b over 2a, or its bottom, and that's going to be -2 over 2a. We know that, well, we can plug it in here, but a is just equal to 1, so it's a -2 over 2, which equals -1. So we know that its peak or its bottom is going to be at x equals -1. And when you plug that into the equation, we're going to have y equals -1 squared plus 2 times -1. That's going to be 1 minus 2, which equals -1. So we know that its peak or its bottom is going to be at -1, -1. And if we look at the graph we made for this earlier, that lines up. We can see, I think we plugged in -1 for this point, -1, -1 right there. And in this case, it's going to be the bottom. And unless you know some more difficult math, the only way you can do that is basically drawing it out. And that's a perfectly way of doing it, no shame in that. But down the road, there are more elaborate and complicated ways that you can figure out that's the true value. Now, another way that I wanted to talk about finding the intercept is something that might be a little more intuitive. So we know that y equals 0 at 2 points for the quadratic. Okay, and up here that we said that x can equal 0 or x can equal -2. And this is where an important idea of symmetry falls into play, and that's why I wanted to mention that the quadratic equation is symmetrical. So since in the quadratic equation, we're going to have this U shape, and we're going to have 2 points, we know that the middle is going to be exactly in between those 2 points. So we know from our math earlier that the middle is at -1. However, if you already have the roots where y equals 0, what you can do is find the middle point. So 0, and then let's draw a little number line. -2, we know that the middle is at -1 for x, and you can plug that value in, which is what we did prior with the other equation, and find what y value that equals. Or another easier way of doing it, if you don't want to draw the number line for maybe 30 numbers or something, you can just add up these two values and divide by 2 to find the middle, which is -2 over 2, and that's equal to -1. So this was a lot of setup, and the setup gets us to the main course of today's lesson. And that's just going to be factoring, and we'll say this is the general case. So this is the case that you will see most of the time when you're asked to factor out a quadratic equation. And let's write that equation just to familiarize ourselves again. Y equals ax squared plus bx plus c. Okay? Now let's get into some examples because that's going to help us understand how to factor out these problems. So when I say general case, we're going to be using a, b, and c. And that's why it gets a little more complicated. It's not an easy solution to find anymore because you have c involved and not just x's. So the best way to explain it is just to jump into an example right away. Let's say we have y equals 1x squared, and I write that 1 although it doesn't have to be there. It's going to help us, especially for starting, plus 6x plus 5. So this is going to be the first equation that we're working with. When it comes to factoring, and an important detail for this example, and the a value is equal to 1. That's very important because if it's not equal to 1, it's a little more complex, although not too bad, and we'll get into examples of that, but a equals 1 is going to be your base case. We're going to draw out this x, and it's just a visualizer that helps us understand it a little better. And in this top thing, you're going to have a times c, and in this bottom one, you're going to have b. Okay, so let's draw that out. We know that a times c is 5 and b is 6. So when it comes down to this, the main idea is that, let's draw this out. So you have these two things, these two numbers that we're going to determine, they multiply to the top value and they add to the bottom value, and that's incredibly confusing, and that's kind of the story of quadratic equations, is they're confusing to start with, but once you do enough of the problems, they're going to be very familiar. So I mean, I know that two whole numbers off the top of my head that multiply into 5 are 1 and 5. Those the only case, only two factors, so we know that 1 and 5. So we can see that they multiply. 1 times 5 is 5. They multiply in this top number, and they add into 6. 1 plus 5 is equal to 6. And now, when you found these two numbers, 1 and 5, those are your important numbers. So you're going to be multiplying two sets of parentheses by each other. And you're going to have x and x. And then you're going to have plus, and then you plug in your values. So we had 1 and 5 here, x plus 1, x plus 5. And now you're saying this is equal to y. So x plus 1 times x plus 5, both in parentheses, is the same thing as saying 1x squared plus 6x plus 5. We just broke it up into two smaller parts that we could work with to find an answer. And when I say find an answer, is because we know that we want y to equal 0, and that's the point where our parabola touches the x-axis. So here we see that to make this 0, x has to equal -1. And that to make this 0, x is equal to -5. And that goes back into when we started explaining this, and that anything multiplied by 0 is 0. So we want to find when each part is at 0. So this first part is at 0 at x equals -1. The second part is at 0 at x equals -5. So this would be our two answers. X equals -1 and -5. And these little curly braces here is how we can say that x is equal to more than one value, which is something that you normally don't see too often in math. Okay, so that was kind of the basic example. And for this next example, we're going to look at another one of the simple ones just for practice. 2x minus 8. We're going to draw out our x right here. That the top value is a times c. We know that a in this case would be 1, it's just not wrote in there. And that c is negative 8. Keep in mind that the negative is very important. Negative. And that b goes in the bottom. So we need to think what two numbers multiply to negative 8 and add up to 2. So I know it's going to be 4 and 2 of some sorts, and that we have a negative, so negative 2. So 4 times negative 2 equals negative 8, but 4 plus negative 2 or 4 minus 2 is equal to 2. So these two values are our important x values. We can draw these two out in parentheses, saying x plus 4 times x minus 2. And that's the same thing as the original equation over here. We'll multiply it throughout. And we know from here that to solve each of these, we set them equal to y, which is equal to 0. So each of these parts need to be 0 when plugging in an x value. This first one's going to be x equals negative 4. And this next one, it's going to be x equals 2. So x equals negative 4 and x equals 2. Now looking into the complex problem that you may run across. Your teacher may expect this out of you or may not. This is going to be when a is not equal to 1. So things aren't going to be as rosy and easy as they were before. We're going to start with the equation y equals 4x squared plus 2x minus 6. Now, when it comes to the complex problem, you're going to start in the same exact way. You're going to have a times c at the top. 4 times negative 6 is negative 24. At the bottom, you're going to have 2. So for this one, we're going to have 6 and 4. The top is negative. We know that making negative 4 would allow us a positive on the bottom. 6 times negative 4 is negative 24. 6 plus negative 4 or 6 minus 4 is 2. And normally at this point, we would just jump straight into the parentheses and solve for x. When it comes to the complex version, because a is not equal to 1, it's a little more complicated. So you can keep that first value, 4 equals x squared, but now we're going to change the middle value, 2x, into two values that we just found. And that's going to be plus 6x and minus 4x. So 6x minus 4x is 2x, so we didn't change anything in the problem. We just expressed 2x in a different way. And then you keep that last value, which is negative 6. When it comes to the complex form, you're going to have your first two values, you're going to have your next two values. So when you have this step, what you're going to do is pull out the greatest common factor of both parts. So 4 and 6, the greatest factor of that would be 2. And then we can also pull out an x because both have x values. So we're going to pull out 2x, or 2 times x, make a parentheses here, and think what times 2x equals both of these values. Okay, for 4x squared, we're going to have 2. 2 times 2 is 4. And then x, because x times x is x squared. We have the plus sign here. And then 2x times 3 is going to be a 6x. So for this next one, we're going to have minus, because we have a minus here. We know that 2 is greatest common factor. And then we're going to have 2x. And we can't pull an x out of that second value, so this leading coefficient is just a constant. And 2 times 3 is 6. And since we already have a negative 2 here, that's fine. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. So this bottom equation of 2x times parentheses 2x plus 3 minus 2 times parentheses 2x plus 3 is equal to 4x squared plus 6x minus 4x minus 6, which is equal to the original equation of y equals 4x squared plus 2x minus 6. So we haven't changed anything about that original equation, and that's exactly where we want to be. We don't want to change what we're working with. We just want to talk about it in a way that allows us to find an answer. And that's what this is. Now when you're at this point in the equation, you're going to have two more things to look at. So a lot of 2's here going on. You're going to have the parentheses. And the other thing is you're going to have everything else. So to start, we're going to have 2x plus 3. We're going to get this in a form of multiplying two things so we can find when it's equal to 0, what we've been doing all along. And that the other parentheses is just going to be what else you have. 2x, which, let's write this in another color, just express it a little easier. We're going to have 2x minus 2. That's everything else. So 2x plus 3 times 2x minus 2 is equal to everything up here. So everything has been equal so far, and that's exactly where we want to be. And this is going to be equal to y. And we know that we want y to equal 0 because that's when we touch the x-axis. With that in mind, let's solve for each of these parts. So the first one will be x equals x equals negative 1.5, and that's just because 2x plus 3 equals 0. 2x equals negative 3. Divide that by 2 on each side, you're going to have x equals negative 1.5. And then for this one, easy kind of plug in. We know that 2 times 1 is 2, minus 2 is 0, so x equals 1. And there we go, that's the answer. So x equals negative 1.5, these are curly braces, and 1. So a little more complicated and understandable if it takes a couple of times to wrap your head around it. Just know we start in the same way. We use those values to replace that middle x value. And then we go through the solving process, which looks like just breaking it into factors and then changing that into our final form. And then we get our x values, which cause y is equal 0. Now, one last thing to keep in mind. So this is pretty much the majority of what you need to know when it comes to these problems. But I would be doing a great disservice if I didn't mention the quadratic equation. Now you might think, oh, there's an equation. Why didn't you just start with that? If there was just an equation I can plug in to find all my answers. And yeah, obviously, why did I just mention that? Well, I didn't mention it because it's complicated. It's not the easiest thing to remember. It's not something like negative b over 2a. And you can just kind of remember that. It makes your life easier. It looks something like x equals negative b plus or minus. You might see that I'm looking over it because I don't have this equation memorized. Hopefully your teacher will provide it to you. Otherwise, it's something you just have to memorize. And this is all over, let's see, 2a. Yep. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And yeah, that's a mouthful just to say, and it's a mouthful to work with. But we will do it for a problem just to see how it operates. So, and I'll show you why this is important, because you might think, all right, I'm not going to remember that. I would rather just stick with our x's and know the process. And it is great to know the process. However, there's times where our process just doesn't work. You might think, well, okay, when doesn't it work? Well, we know according to our process, this top value is going to be negative 3. This bottom value is going to be 3. Okay, so next step, what two numbers multiply to equal the top and add to equal the bottom? Well, 3, you can only use 1 and 3 to multiply, and neither of those are going to add up to 3, so there's not really an answer we can use. And well, that puts a wrench in our plans. We can't use our process at all. And although the same idea would still apply if you could think of all these decimal numbers, you're not going to be able to think of decimals to 3 or 4 places that multiply to the top number and add to the bottom number. Instead, you're going to use the quadratic equation. And that's going to look like x equals negative b, so negative 3 plus or minus square root of b squared, 3 squared, minus 4 times ac, 4, a is 1, c is negative 3. And then we're going to have 2 times a, which is 1. So we're not going to go through solving the entire thing, but just know this breaks up into 2 things. Because there's going to be 2 answers. It's quadratic. Remember, there's always 2 answers unless you just have the basic one that touches at the origin. So for this top one, you have 3 plus square root of 3 squared minus 4 times 1 times 3 all over 2 times 1. And for this next one, you're going to have negative 3 minus 3 squared minus 4 times 1 times 3 all over 2 times 1. So now this goes to say when you have a plus or minus sign, that means you're going to have two different equations. You're going to have an equation where at that point you add, you're going to have another equation where at that point you subtract. And when you take both of these, you're going to get x is equal to two values because we have two equations. So you'd hope that brings two values. Negative 1.5. Oh, sorry, that was our prior problem we did. We're going to have x equals negative 3.79 and 0.79. So when you use both these equations, that's the answer you're going to get out. And those are the 2 points where the quadratic touches the x-axis. So although I haven't graphed this one, we're just going to say, let's say this is about negative 3.79 and this is about 0.79. Okay, and it seems like this is going to be an upward facing one. Let's draw an attempt at a better line than that. So say it's something like this. This might be completely off, but just for graphing purposes and to show what we're doing at the end of the day, it's to solve these. So that's the quadratic equation, and it comes into processes where we can't use our standard method of solving. So we need to use the actual equation to find the answers. And one last important factor, and just a quick side note, is that sometimes when you use the quadratic equation, you're going to get an answer. And you're not going to know how to solve it. And the reason for that is you're going to have the square root of a negative number. And if you take a second to think, no two things multiplied by themselves equal a negative. And that would be correct. And what that's going to look like on the quadratic equation is simply saying that the quadratic equation never touches the x-axis, which is totally possible. I mean, if you have something like y equals x squared plus c, as long as c isn't negative, any value you plug in c, 1, as long as it's not negative and not 0, any value you plug in for c, 1, 2, 3, 4, it's never going to touch the x-axis, and you're going to end up with a square root of a negative. And this gives something, as a quick side note, imaginary numbers. And this is be your first introduction to them. I'm not going to go into it in this video, but rather another video. We can kind of express it in a little funky way. It's just saying that it doesn't touch with any numbers that make sense in real life, basically. No numbers on the number line can make this equation touch the x-axis, and that's perfectly fine. It just means there's no answers, and you might just have to put no answers until you know how to work with imaginary numbers. But for now, if you use a quadratic equation, or you draw out the chart and you realize, hey, this never touches the x-axis, the answer is that it doesn't have any answers. So beyond that, this is all the basics when it comes to a quadratic equation from everything that you'll need to know at the very starter level. Go through the equations, practice, find equations online, practice solving those, and once you do it repeatedly over and over, it's going to be very difficult to forget. Thank you for tuning in. I hope you guys subscribe, like the video, share with your friends, share with your teachers. Hopefully you got some help out of this. But thank you for watching and sitting through the video. Take care, and I'll see you guys in the next one.